All right, so good morning, folks. This is Mike coming back at you with another video on Intro to Algebra. In our previous video, we began to talk about the greatest common factor, not just the greatest common factor of two or more numbers, but also two or more algebraic expressions, things containing variables and powers. And we talked about how to figure out what that greatest common factor is. Now we're going to talk about factoring a polynomial by pulling out that greatest common factor. So when we have a polynomial and we have found the GCF, or greatest common factor, of the terms in the polynomial, we're going to pull out the GCF from each term. And really what I mean by pulling out the GCF is that we are going to divide the GCF out of each of the terms. And we find what is left over. We rewrite the polynomial as a product, and this process is called factoring the polynomial. Another phrase you'll hear is that when we pull out this greatest common factor, you'll sometimes hear it called factoring out the GCF. And what we're really doing here is we're using the distributive property, but sort of in the opposite way. What we're used to doing is say something like 2x times x squared plus 2. We are used to being handed something like this, and then we distribute the 2x into each of these two terms. So we'd have 2x cubed plus 4x. That's what we're used to doing, and that's what we are used to seeing. But now we're sort of going in the opposite way. We're going to be handed something like this right here, and we have to look and say, okay, what is the greatest common factor between these two terms? Then we have to pull out that common factor, and we have to write it as something like this. So we'll do some samples here so you can see what it is we are talking about. So first sample here, given the polynomial x to the fourth plus 2x cubed minus 5x, we want to try to factor this thing. We want to factor out the GCF. So the first thing we have to do is figure out what the heck the GCF is. Well, we said from our previous video, if we are looking at all of the terms, the x to the fourth, the 2x cubed, and the 5x, we have to find the GCF of the numbers in front. I'll write these terms over here to the side. We have to look at the numbers in front and find the GCF of those numbers in front, and then we have to find the GCF of the variables and their powers. So the greatest common factor of the numbers in front, that is of 1, 2, and 5, is just going to be 1. So you could write the 1, but typically we don't write that. But now we have to look at the GCF of the x to the fourth, x cubed, and x. We said that as long as the variable is showing up in each of the terms involved, then the variable is going to show up in the GCF. So our GCF is going to contain x. What power are we going to have on the x, though? Well, the power that we're going to have is the smallest power that is appearing in any of the terms. So here I have a power of 4, here a power of 3, and here a power of 1. So that means the exponent on the variable in our GCF is going to be the 1. So the GCF is x, and we see that written here. But that's why our GCF is what it is. So now that I've identified the GCF, I take my polynomial, I rewrite it, and now what's really going on from here to here is the following. I am really doing x to the fourth power plus 2x cubed minus 5x, and I am dividing all of that by my GCF. I am dividing everything by my greatest common factor. So that gives me x to the fourth over x plus 2x cubed over x minus 5x over x. And we say, okay, what is x to the fourth divided by x? Well, that gives me x cubed plus 2x cubed divided by x is 2x squared. And then minus 5x over x is just 5. So in this step here, that's why I wrote the x times the x cubed, because that gives me the x to the fourth. Here I have the x times the 2x squared. That gives me the 2x cubed. And then here I have minus the x times the 5. That gives me the minus 5x. So we see that this x does appear in each of these terms. And this is where we are pulling out the x from each of these terms. And you see the x is happening in each of these three places. We pull them out. We pull them out of each term, and we write it once out front, and then in our grouping symbols, in our parentheses, we write the polynomial that we got as a result of dividing the given one by our GCF. That's why I say it's x times x cubed plus 2x minus 5. So this is just one sample of factoring out the greatest common factor of a polynomial. Let's go on to some of these other samples here. First one, 2x to the sixth plus 8x to the fourth minus 12x to the fifth plus 6. So again, first thing we have to do is we have to find our GCF. We're just going to focus on the terms themselves. So 2x to the sixth, 8x to the fourth, 12x to the fifth, and 6. So first thing we need is the GCF overall, but within that GCF, we need the GCF of the numbers in front. So what is the greatest common factor between 2, 6, 8, and 12? Using the method that we talked about in the previous video, or just looking, shouldn't take too long to figure out that that GCF is going to be 2. So that's the GCF of the numbers in front. Now we see if an x is going to show up in this at all. Well, the first three terms contain an x, but the last term, the fourth term, does not. Since the variable is not showing up in all of these terms, the variable x is not going to show up in our GCF. So the GCF in this case is just 2. So now what I'm going to do is I'm going to write, I am going to divide this polynomial by my GCF. So I have 2x to the sixth divided by 2 gives me x to the sixth. I have 8x to the fourth divided by 2 is 4x to the fourth. I have 12x to the fifth divided by 2 is 6x to the fifth, and then 6 over 2 is 3. So that means I can write this polynomial here as my greatest common factor 2 times what I got here, x to the sixth, and I will write this in a descending order of power to remain consistent. So 2 times x to the sixth minus 6x to the fifth plus 4x to the fourth plus 3. You can check, you can distribute or multiply this 2 into each term, and you will come up with this thing here. Let's try this one down here. 12x cubed y squared plus 30x squared times y to the fourth minus 36 x to the fourth y cubed. So again, we're just going to look at the terms first of all. First thing we need to do is find our GCF. So to find our GCF, first we need to find the greatest common factor of the numbers in front. So the GCF of 12, 30, and 36. Again, using our method from the previous video, you can check and you'll find that the GCF is going to be 6. Okay, let's see if any x's are going to show up in my GCF. This term contains an x, as does this term and that term. All the terms contain an x, so an x is going to show up in the GCF. What's the exponent going to be? Well, here there's a power of 3, here there's a power of 2, and here there's a power of 4. The smallest exponent is the 2. So that's going to be the exponent on my x in the GCF. Is the y going to show up? Well, y is happening in each of the terms. So what is the exponent going to be? Well, here there's a 2, here there's a 4, here there's a 3. So the exponent is going to be the smallest power on the y, which is 2. So the GCF is 6x squared y squared. Now, let's take our polynomial, divide it by the GCF. So 12x cubed y squared plus 30x squared y to the fourth minus 36x to the fourth y cubed, all divided by 6x squared y squared, and we shall see what we get. So, first term divided by the bottom. 12 divided by 6 gives me 2. Then I have the x cubed divided by the x squared, that gives me x, and y squared divided by y squared, that's just 1. Those things cancel out. That's all fine and dandy. Now, next term on top divided by the bottom. 30 divided by 6 is 5. X squared divided by x squared is just 1. They're gone. Y to the fourth divided by y squared is y squared. And now last term divided by the bottom. 36 divided by 6 is 6. X to the fourth divided by x squared, using that quotient rule for exponents, it's going to give me x squared. And y cubed divided by y squared is going to give me y. So this is what we get when we divide our given funky looking polynomial by the GCF. So we say that this thing right here equals my GCF, 6x squared y squared times 2x plus 5y squared minus 6x squared y. So that one was a bit more challenging, certainly. We'll be focusing on more problems like this guy here when we are in class. So there's one other sort of form of factoring that I want to show you. Sometimes you can factor a polynomial by sort of regrouping terms and then finding a common factor that way. And you utilize this trick, you use this method when there is a common factor between some terms in a polynomial, not necessarily all terms. And this does take some practice to sort of really see where we can use this, but I will show you some samples of how we could potentially use this to help us factor this kind of thing. So we're going to factor 4x minus 8 plus ax minus 2a. So we are throwing in another letter here. That's okay. What I want to do is I want to just sort of group some of these terms and then focus on these groups. I want to group these two things together. So I'll look at the 4x minus 8 as being one thing, and then I want to look at the ax minus 2a as something else. And what I'm going to do is I'm going to factor each of these things separately. So if I look at the 4x minus 8, what is the GCF, greatest common factor, of 4 and 8? Well, that's going to be 4. So I'll do some work on the side here. GCF for the first group so the GCF of 4 and 8 is 4. This term contains an x. This term does not. So the x is not going to show up in this GCF. If I do 4x minus 8 divided by 4, that gives me x minus 2. So this thing right here is 4 times x minus 2. Plus, and now I'm going to find the GCF for this second thing, for the second group. Well, I look at each of these terms. You know, you look at the number in front, the 1 and the 2. The GCF of 1 and 2 is 1, so we don't have to write anything for that. The first term contains an x. The second term does not, so there's no x that we're putting in here. But the first and second term do both contain an a. So that is a common factor between those two terms. So the GCF of the second group of things here is going to be a. And if you do ax minus 2a divided by a, that gets you x minus 2. So we have this thing equaling a times x minus 2. Well, this thing has an x minus 2 in it as a factor. This term has an x minus 2 in it as a factor. So now looking at these things as entire terms, they have the common factor of x minus 2. So I can pull out that x minus 2. And what does that leave me with? Well, if I move the x minus 2 out front from there, I'm left with 4. If I move the x minus 2 out out front from there, I just have plus a. So I have x minus 2 times 4 plus a. And this is how we could factor this thing using this sort of technique, using this tool. I do want to stress that this doesn't necessarily always work, but when it does, it is very, very, very nice. We'll do one more sample problem. We'll look at this one here. 10x cubed minus 8x plus 5x squared minus 12. Again, I'm going to look at sort of the natural, sort of natural grouping that is presented to us. I'm going to look at the 10x cubed minus 8x and the 15x squared minus 12. I want to find the GCF of each of these groups of things. So the GCF of the numbers in front, the GCF of 10 and 8 is 2. The GCF of the variables, they both contain an x, so the x will show up. What's the power going to be? Here the power is 3, here it's 1, so it's just going to be 1. So the GCF is just 2x. With this grouping here, the GCF of 15 and 12 is going to be a 3. And then is the x going to show up in the GCF of this sort of grouping? Well, there is an x here, but there isn't one here, so no, the x is not showing up. The GCF of this grouping here is just 3. So I have to divide each of these groupings by their respective GCF. So 10x cubed minus 8x divided by 2x equals, this is going to be 5x squared and then minus 4. If I do 15x squared minus 12 divided by 3, that's going to give me 5x squared minus 4. So this term right here is equal to its GCF, 2x, times what we got when I did my polynomial division, 5x squared minus 4. Plus, now this term, or this grouping here, is equal to its GCF times what we got when we divided. Well, just like the previous problem, we see that looking at this as one whole term and that as one whole term, there is a factor of 5x squared minus 4 here. There's a factor of 5x squared minus 4 here. So I can pull those factors out front. And that gives me 5x squared minus 4, the thing we pulled out front, times, now what's left over? The 2x plus 3. And there we go. So that's how we can factor this thing here, utilizing the greatest common factor. This is admittedly kind of an odd way, not necessarily something that is the most obvious to think of, and not something that we'll necessarily be using a lot of. However, I did want to just show you this, just so at some points in the future, if you do see this popping up, you'll say, oh yeah, this does ring some bells vaguely. In the next video, we're going to move on to section 5.2, and we are going to talk about factoring trinomials. This is something that some of you, if not many of you, have already seen, and sort of a little bit of puzzle solving here, kind of. So we'll get into what we have to do to factor trinomials in that next video. If you have any questions or comments, please be sure to reach out to me, guys. email, voicemails, visits in my office hours, visits in my tutoring hours, carrier pigeons, SOS bonfires, bat signals, telegrams, messages on blimps flying through the sky, whatever you have to do. Until the next video, take it easy, guys.